Alright, ya comenzó.
Alright, go ahead and, I'm going to recommend that you keep this do first out. Because these steps that we're using for factoring, you will need them later on in the classwork. Like you'll need to be able to factor like what we did in the do first later on. So it might be helpful to keep these out. Alright, if we look at exercise 1. We're asked to solve for x. So when I have x minus 10 equals 0, how do we solve for x here? Well, we do both sides. What do you think, Abby? Add 10 to both sides, perfect. We get x equals 10. And then we got x divided by 2 minus 20 equals 0. How could we solve this? Ooh, Maria said multiply by 2. What's multiplying by 2 going to do? It's going to get rid of this fraction right here. So, please remember, I know it's been a while since we've done it yesterday. Yeah, go ahead, go back. When we multiply a fraction by its denominator, that cancels out, we're left with our x. So we'll have x plus 2 times 20 is 40, and then 2 times 0 is 0. Then how do we solve it? Great. So then we get x equals negative 40.
But why did you check 40?
Because we were adding it, and the opposite of adding is subtracting. Alright, so was solving these equations that hard?
No.
Hopefully it wasn't. It shouldn't be. If this was August, that'd maybe be different. No. I don't think the hardest thing for today is the factor. That's what everyone's having trouble with. So here's the idea that I'm going to teach you. What if we had some number A times some number B equal to 20? What could be one of the possible combinations of A and B? Yeah, 5 times 4? 5 times 4 words? Y'all can just yell them out. I don't mind.
1 times 20!
Alright, I heard this one. I heard this one.
100 times 80. What is it?
Well, we're multiplying here.
100 times.
You know how you could use 100 as a factor?
100 divided by 2.
100 and 1/5.
1/2. Oh, well, 1/5.
So what's 100 divided by 5?
120.
You could also do 40 and 1/2. Because 40 divided by 2 is 20. You could do 60 and 1/3. 60 divided by 3 would be 20. So all these work. So what's the point? What am I trying to make?
Factors.
If our factors, if we are multiplying to a number like 20, can it really help us know what our values are?
No.
No, it can't. But what if we change this 20 to a 0?
0 and 0, 5 and 0, 10 and 0.
Alright, Jason's on the right track.
Everything is 0, 2 and 0. Everything is 0.
All their numbers.
So if we had like 68 times A equals 0, what would our value of A be?
0.
Great. What if we had like 47 times B equals 0?
0.
B would be equal to 0. What about A times, I don't know, 1,812?
0.
A would be equal to 0. So what can we assume? If what we're multiplying to equals 0,
That
what
the
can we
variables.
assume about one of our variables?
That there's 0.
That at least A or at least B is going to be equal to 0. Back to our classwork. Here we have x minus 10 times x divided by 2 plus 20 is equal to 0. So we have one factor times another factor equal to 0. The x minus 10, that's like our A. And then the x divided by 2 plus 20, that's like our B. So A times B equal to 0. So what can we assume about one of our groups?
It's gonna be 0.
That it's going to be equal to 0. Using this idea is how we're able to solve for quadratics. This right here, it's factored, but it is a quadratic. So how we solve it, we're assuming either x minus 10 equals 0 or x divided by 2 plus 20 equals 0. So we split it into two different equations. X minus 10 equals 0, or x divided by 2 plus 20 is equals. How did we solve this one?
Add X.
Adding 10, x equals 10. What was our answer for the second one?
2. You add 2, you multiply by 2.
You would multiply by 2 and subtract 40.
And then
X
you
equals
get
negative
20.
40.
And then you get negative 40.
Great, thank you.
Oh,
Wait, or? What does that mean?
That looks like a 90.
like either
Sorry. Like x could be equal to 10, or x could be equal to negative 40.
Because we need one of them to
But
be.
there's always going to be 2 answers. 2 possible answers.
Not always, most times.
one. Wait, mister,
You'll see, I'll talk about that in a little bit. Yes, Jason.
did you multiply, how did you get 40? Negative 40, sorry.
When we solve the equation up here, we multiplied it all by 2, got rid of our fraction, and we had x plus 40 equals 0, subtracted 40.
Wait,
Yeah, these are the same two equations we solved them. Alright, notes.
10 page.
0, no, write this on the front, please. 0 product property.
That's what it calls.
That's what this idea is called, where if we're multiplying two things and it's equal to 0, we can assume one of them is 0.
Mr. We forgot to put R and 0.
I wrote it, but it's just missing.
So everything we get with the cookie equals 0.
Alright, so when multiplying, to 0, when we're multiplying and our product is 0, one of the factors, or both factors must be equal to 0. Must be equal to 0. So that's it in like a nice, maybe not super nice, but a sentence at least. But as you may know, I'm a terrible writer.
No, you're not.
So I like using math symbols. So in math, if A times B is equal to 0, then A is equal to 0 or B is equal to 0.
Is that how you can roll it?
Oh, because either way, like number multiplied by 0 is 0.
That's it. That's exactly the idea that we're at. Thank you, Esther. Let me write that down. I know it's a lot to write, so I'm just one.
You're the best teacher ever. Shut up.
Now I gotta delete it. I just don't see.
Hey, because
Miss Taylor, ignore that part.
it's because Angel even told me to say I feel smart, and that's why I started laughing.
Wait, I'm sorry. Did y'all have that written down?
yes, yeah.
Yo.
We're playing. Hey, don't, please don't say that in front of the C-A-M-E-A-R.
I don't know how to spell camera either. It's okay.
Oh, I don't know how to write, yeah.
Alright, if we look at example E.
You love cameras.
Sorry, I'm almost done, you know. Well, not really. We're almost gonna have snack. For example E, we have x minus 4 times x plus 3 equals 0. So one of our groups, the x minus 4 or the x plus 3, has to be equal to what for this to be true?
0.
0. So here's how we solve it. X minus 4 equals 0, or x plus 3 is equal to 0. Well, we got to solve it. We have to get x by itself. How do we get x by itself? Add 4, x equals 4, or subtract 3, x equals negative 3. Because if you plug a 4 into here, you would get 4 minus 4 to 0 times 4 plus 3, which is 7. What's 0 plus 7, or times 7?
0.
0 times 7 would be 0. Anything times 0 is 0. That's why this works.
0.
Alright, last thing I want to show you before we really start practicing this.
So it's how many equals?
So basically, it's just like you're finding the number to plug in because 4 minus 4 is 0, and then negative 3 plus 3 is 0, so that means 0 times 0 is 0.
What?
I'm trying to make it true.
You're trying to see what values of x will make this true. So we can say if x is equal to 4, then we can and plug that in. You would do 4 minus 4 times 4 plus 3. Does this equal 0? Well, 4 minus 4 is 0. 4 plus 3 is 7. What's 0 times 7?
0.
Should be 0. And then if you plug in a negative 3, negative 3 minus 4 times negative 3 plus 3 equals, we'll see, does this equal 0? What's negative 3 minus 4?
0. Oh, 3. Negative 1.
Negative 7. And then negative 3 plus 3, that's your 0. Negative 7 times 0
Oh.
would be 0. So the OR is 4 makes this true, negative 3 also makes it true. That's actually the next thing I want to show you of like what we're actually solving for here. So I want you to have an idea on like what these numbers mean. And the way to do that is to look at the graph. I gotta erase this. Good question, Abby. Alright, so I'm just gonna graph x minus 4 times x plus 3. Graph it. It's a little hard to see, so I'm gonna draw on it. Somebody else see it, maybe.
Is that quadratic graph?
Yeah, all these are quadratic, man. They're parabolas.
Whatever that word is.
It's the shape of the graph, Jason.
A football?
Nope.
The graph,
It
not
doesn't
the line.
come back like this.
Will it ever?
It's a semi-football.
Where's this graph crossing the x-axis? These are counted by ones.
Oh.
3 and 4.
Right here, this is not positive 3.
Negative 3 and
Negative
positive
3.
4.
Positive 4.
So what we're solving for here is our x-intercepts on the graph. So that's what these numbers mean. I wanted to give you an idea on what these numbers mean today. We're gonna, it's not really cheat code. We're gonna look at the graphs more in detail next week, but I just wanted y'all to know what these numbers were today. I thought it would be helpful. Alright, let's have some.
Mr. Why did Jonesy leave?
I don't know what you just said.
Oh,
Jonesy.
Oh, he said he wasn't feeling well, man.